Today it's Walkie Talkie Wednesday, and I was asked if I would do the Sirtel hand portable, which is made by Great, like the Fidelity 1000 was made by Great, and it's unusual in so far, well, it's unusual in being huge. It's even bigger than the Binatone Long Ranger 40. Metal cased. It's unusual that it's got an S meter. Got high-low power on the front, in line with 2781, so it'll be 0.4 watt and whatever watts, something near 4. And might gain high and low. That is interesting because if you've got if you're in a noisy environment, you'll want that on low and you'll be talking into it. And on this radio, the bottom really is a microphone. Just get back to it. If I recall rightly, this was the only one of this chassis which had all the crystals factory fitted. So what have we got there? Oops, that's the extent of our focus. So 1, 9, 14, 19, 30 and 40. So the fact it has 30 means it will communicate with a lot of other crystal controlled sets, but not the realistics. And hopefully we have an intact telescopic. If I manage not to poke the camera, we'll better put that back down. So it'll be made in Taiwan, which it is. We've got a date code, and it's April 82. And as ever, the battery pack is missing. So you end up with these on eBay with somebody putting a PP3 9-volt battery, and then they wonder why it doesn't work. So I'm going to open it up. Oh yes, what we've got at the side. Charge and power. So we've got no external antenna, and the belt clip on this one is broken off. So without an external antenna socket, it's a pain to do anything with. And it also means that we can't put it on the bench and talk to Mr Chippie, so we can only do a field test with it. I remember when we did the field test in 1983, before there were video cameras, or certainly before there were affordable video cameras that didn't take 3 men and a backpack, that we've tested one of these in the series, because there's the Great itself, there's the CTVR, there's the Sirtel, there is definitely the, oh, it's probably come to me during this video, I've just won one on eBay for far too much money, and it's on Merit, that's it. If I recall rightly, they only ever have the one channel fitted. So I'm going to unscrew this, we'll pause the camera, let's see what's inside. Well, one thing I was right on, it does have a full population of crystals, and at 30 quid a pop these days you got 360 quid worth of crystals. And you can see, you know, it's got some real output. It does have a proper output transistor, not like that Kaiser with its lying thing that said 4 watts when it clearly couldn't be more than 1.8. So you've got a half decent output transistor. I'm gonna look up the file for these, because I don't know whether it's sold as a 4 watt set or a 3.5 watt set or what. But you'll see it is very reminiscent of a Fidelity 1000 or one of the GT8 58868 radios, in the way the coils are, the type of coils, and the type of capacitors, and just the whole build arrangement. So, and of course it is made by Great in Taiwan, and you've even got bits under there, and you have a real electret microphone. The big resistor there will be the charge limiting resistor. So I've just got to do a little tiny bit of research and see whether we're supposed to have a 8 times AA or a 10 times AA battery pack on these. I can't remember what the voltage requirement is, and it doesn't say so on the back. And then we'll got to get our handy crocodile clips onto there. But it's not going to be easy to service because, as ever, we can't get to anything. It's going to mean pulling the board out because it doesn't have an earphone socket to enable me to get to the other end of the speaker. No wonder I've been putting these off. Right, so what we're left with, I've plugged it in. Well, we've got low battery light and I'm running at 12 volts. So it's 8 pen light cells, so that's 12 volts. It says 1.4 microvolts are better for 20 decibels cyanide. It says output power is a maximum 4 watts. It doesn't say there's a minimum. And what I've done is to remove the telescopic aerial, can't even say that. And what we have is a screened lead, which means that we're straight into the bottom of the loading coil. We're still not going to get true readings because of the loading coil in the way. So between there and one of these cans, we should yeah. That's worrying. Of course, that's full pelt of the signal generator. Okay, let's look at transmit. So I better just check that we're on high power. Put mic gain to high, attenuator off. There we go. I'm definitely running at 12 volts though, so I can't see why we've got a battery light on. I'll tell you what, I'll turn it to 12.4. We've still got a battery light on. No, I don't know what's going on there. Could be a fault with the battery test circuit. There's a Zener in there. So I've got the layout here. I've got the circuit diagram here. I've made some notes. Interestingly, there's a loop that comes of bare wire just there. I wonder if that's supposed to be the test point for the output. Let's put the crocodile clip on there, and we'll see. Nope, we get nothing there. So we'll go back to where we were. Okay. So, virtually full scale deflect. Well, it's 2 watts, isn't it? Yeah, just under 2 watts. So if we go through the transmitter lineup, it'll be, I think L12 is frequency, and it is slightly low. It should be 89125. It's 89056. That's still in spec. I'm just going to sneaking suspicion that L12 could be adjusting the frequency. From the circuit, if it is indeed adjustable. It's adjustable a little bit. So we've got it up to 9050. So it should be, yeah. I mean, it's near enough, that. And of course, they aren't individual trimmers, so we're going to do channel 30, and we're going to do the best we can with channel 30, because I've no intention of playing with it on other channels. Okay, so we've got maximum there. That was T6, L16. Onto the tool again. What's this? T5. So we've just got a shade under 3 watts there. But as I say, we can't be sure as to how the loading coil is affecting the radio. I'll optimise that later with the field strength meter. Okay, so let's have a look at deviation. So I better retune the test set, because we're doing channel 20 last. Wallow, that's it, that's activating. Right, let's cut this on, line that up under the microphone, press transmit. That's very low. Let's see what the adjustment is. So I know that SVR1 is estimeter, I know that SVR2 is squelch, I know that SVR4 is the power meter, but I've no idea where they are on the board, so it means absolutely nothing. With this one at the top. It'd be easier for me to set this on a different scale. That appears to be it. I'm getting an RF burn off this radio. That one. Oh, that's well over the top. Wow, that's okay. So, deviation is the preset just there. So we'll kind of draw it in. So we probably have an RF one. There's a bare wire here which I got a nice RF burn from just now, and I would think that's the sensor for the RF meter. So let's kind of key it up. Look at that meter, which shows a nice healthy between 3 and 4, which is where you would expect. It's very difficult with this all in bits and the board dangling out. Let's try the other one down there. It is that one. So the bottom preset is the power meter. I'll make a note of that. So that should leave those two to be squelch and S and RF meter. So that's done to transmit. I don't know what's up with the receive. Oh, that's a bit better. I say a bit better. So with the frequency counter now on the with the signal generator now on the right frequency, that's 3 microvolts. So now we're going to have to connect the test instruments up to the loudspeaker inside the radio. I just so wish I'd put an earphone socket on these kind of things. We wouldn't have had to take the board out if I was able to get to the loudspeaker. Okay, I've got it onto the loudspeaker, and it would be the terminal hardest to get at, which is this side nearest me. It's nearer the crystal bank. It's that terminal of the loudspeaker, because the earth is already going through the test sets from here. So let's see what we're doing. Now these are a strange detector. It's a ratio detector, so it's not a clever chip like in more sophisticated sets. So it's a bit like the Fidelity 1000, but then it's from the same company. So that's too good a signal, so let's turn it down a bit. So I've worked out that it's going to be T2, T1 and L3. I have a layout for that. T2, L2, L3. I don't know why that didn't come into my original plan, but we'll have a look. Okay, so we've gained a bit there. I'm going to turn down the attenuator. So we've now got 1.6 microvolts on the signal generator. That's gained a bit more, so we'll turn down the attenuator. It's 1.2 now on the signal generator. No further improvement. Let's just look at these IF ones. Oh, hang on, hang on a minute. T3 and T4 detector. Yeah, that's that and that. I'll put a bigger signal on. Go back. Make sure that's nothing to do with transmit. Okay, I think that's as far as we're going to go. Let's go through it again and just see whether we can get another fraction out of it. No, that's where we are. You can hear it about 0.7 of a microvolt. But as I say, because we're on these crocodile clip leads, it may not be kind of quite how it should be. And the only way to do these things properly is to take out the loading coil and then have it screened right up to there, but that's not practical. I just wish I'd put an external aerial socket to the far side of the coil. Okay, let's see about squelch. Turn the signal generator off and activate the squelch. Switch the signal generator on. Turn it to full. Do with a bit more than that. So we'll see which one of these presets it is. I think it's going to be that one. I was right. Yeah, it should be alright as a hand portable. It's about, roughly, it's 3 microvolts when it's coming in. On the fine scale, it's actually 2 microvolts when it's coming in. And I've just knocked the thing off frequency again. I'm good at doing that on this. So that leaves us with the S meter. So if that one is squelch, then the other one must be S meter. So at the moment, that's reading S5 and a bit. So I'll try and get the tool into there. And my hand neatly covers it. So we've got something near there. I don't know where it was because obviously I've upset it by fiddling with it. So we'll take that off the speaker now. So it's on its own speaker, and you can see the size of that. It's probably a 3-inch speaker like you get in a mobile. You know, it's incredible, but you've got all this real estate, haven't you, when you've got a set of this colossal size. You certainly hit somebody with it. So we'll make sure that says S meter. So that is it. We'll now make an attempt to put it back together. I don't know why we've got the fault here. It's showing we need the battery changing. We don't need the battery changing. So there's a Zener diode circuit for that, and I did spot it earlier. Anyway, it could be that these Zener diode stuff, so it really doesn't matter. You know, we're doing this, it's not for a customer, it's for me. It's just so we can do a demonstration and see whether we can actually get to scratchy corner on it. And at a good 3 watts output, we should be able to do that. So I'll just put it back together, and that's probably 20 minutes work, so I'll turn the video off. So we've got the board back in, and the idea here is to dress the cables, which is the output to the the rod antenna. So I've got it so that when a screw goes in there, it doesn't pinch the cable. and when a screw goes in there, it also doesn't pinch the cable. So it's all things to watch, stuff like that. So now it's fun time while we try and manipulate the PTT bar to go in the right position. So we've got to groove. I'll get rid of that. We'll open that out a bit. So it's a matter of getting that in the groove. I think we're in. So we'll get the screws in. Okay, well, having gone for a cup of tea and to get a battery holder, get these from the CPC wholesaler. Let's just zoom in on that part number rather than you asking me for them. You may as well get them direct. Okay, so it's an 8x AA holder to a PP3 battery clip as we know it in the UK. There's a lot of people say that we're referring to this type of battery as a PP3, and a lot of people mistakenly call that a PP9 because it's 9 volts. PP9 is the big square one for transistor radios. They can end up ordering the wrong part that way. So I've got 8 brand new Duracells here. We always do these tests with brand new Duracells, and then everything's fair. We ought to test batteries because it could be that some Billy No Mates batteries out there that actually work better. You never know. So that hopefully will go on there. And the radio's sat there hissing now. Does it go that way around? Or does it go that way around? Okay, so it fell at the final hurdle. So what? Perhaps it's a bit bent. There we go. Oh, I'd hate those batteries to fall out of Mr Chippie's feet. Oh my goodness, this weighs so much. God damn. Anyway, it still says replace battery. We're not going to go into that. Obviously, there's a fault with the battery thing test circuit, which is probably a Duff Zener. So I'm going to pull up this aerial without tickling the camera. It actually goes right up to the ceiling beyond the camera. So we're on 1, 9, 14, 19, 30, 40. I'm just going to touch our aerial onto the rod. Well, there's a few noises out there. And that concludes the Sirtel GT417 up to 4 watt 6-channel crystal controlled hand portable from 1982. For watching.